Hi, I'm Andrew Forster, and this is my presentation for the piece of software I've been developing called Rigid Frame. It's a robotics control system, and it is used as a bridge between a physical robot and a person controlling it, or say another piece of software controlling it. It's essentially a system that works like controlling a puppet on strings. There are important areas on the puppet you want to move around, say the head or the ends of the legs. You would pull that string, it would lift it and move it about. And this is pretty much the same way this system works. It's still under development. There's a lot of things I want to do for it. It's written using the Unity game engine. So it's got built-in 3D supports, normally used for Class A games, and it's quite a nice system to work with. It uses the C# programming language, which for me is a bit like a mixture between C++ and Visual Basic. It's quite nice to use. So how does it work? Well, it uses a ball and stick framework system. So each point is connected between different sticks, which have got set lengths, and the software, the simulation, to call it that, is what's keeping those sticks to the right length, and that in turn keeps the whole framework, the rigid frame, sort of all in one, sort of all looking the right way. In the animation at the moment, it's only the two endpoints of the arm which are being influenced in that scene by the two circles. The larger circle is getting it to pull towards the smaller dot, and the smaller circle is actually repelling it from the dot. And all of this sort of working just pulls the whole arm round, pulls it down, lets it go. And what the software would be doing is looking at all the joints on that model and working out the angle. It would then send those angles to a physical robot, and the robot will be moving around, sort of mimicking it. That's the general premise of the robot. What I'll now talk about is 3 of the 4 robots that I've built so far. So the first of my robots is the Servo Walker. Essentially, I felt inspired one New Year's to use small SG90 servos. These are the low end of the scale of servos. They're a bit weak, but they're pretty cheap. You can get a pack of 10 for around 14 to 17 pounds. So they're quite useful. I designed and put together this little robot using Blender, and it worked out quite well to establish the system, the initial version of the software. So on the upper right, you can see where I was initially developing it. I even built a small trailer to hold the battery packs, because as is usual for me, I get really excited when I'm building something for the first time, and yeah, I forget about including a whole load of things like any particular way of just holding the batteries or even any of the electronics. The upper left is kind of its final form. That's what I ended up with it in the end. Unfortunately, the weight of it became just a bit too much for the servos, but it was a nice exercise in getting things working. In the next slide is a sort of a short video of where I was testing some of the early sort of control interaction. So I'm actually using an Xbox controller here to cause it to tilt forwards and just generally move around. Something similar as, well, Boston Dynamics were doing this already with their little robot, and I was just sort of copying the style of it. So here's the Xbox controller, and yeah, I'm just using it to maneuver it. I do in a moment push the buttons to get it to lift individual feet, and this is where some of the flaws you start to see with the software, which in this case there's the first leg, yeah, it falls over. And that seems to be a common feature for all my robots at the moment, is the falling over bit. But all of this helped me sort of refine the software, getting the communication method working. It was using a Raspberry Pi Zero to do all the workings over Wi-Fi. And so the next robot is the Servo Sphere. This is where I wanted to experiment a bit more with the software and have different stances. So the legs would start folded in, and then it would deploy them and then move around. The next slide has a short animation which actually shows the legs deploying and the lid flipping up. This was done in Blender as well. I use it to create the components as well as the animations and any visualization. It's quite a useful piece of software. It also has 3D printing checks, utilities that it can do to make sure the pieces will be 3D printable. Here are some photos of what I ended up building. I have made some more modifications after this, but this is the initial stages. On the left-hand picture, you can see where I used small gear adjustments on the servos. So essentially, the servo, instead of pushing or trying to turn the leg itself, it was turning a smaller gear, which would then turn a larger gear. In this case, the teeth are faced inwards, just sort of inverted. That actually gave it enough strength so that it could keep itself off the floor. This is where I started to encounter a bit of issues with communication between the simulation and the robot. On the upper right, you can see for this case, I was using a Node MCU board, which is Arduino based but uses Wi-Fi. I did start to find some issues with the Wi-Fi, especially if I go somewhere different where I don't know any Wi-Fi passwords. It became an absolute pain to work with. This is the simulation. So again, I've updated the simulation with the model of this particular robot, and this is it's just a general walking sort of style. I use the arrow keys in this case just to move it along, and it works out its own lifting up and moving of the legs, but all it's doing is just moving the end points of each leg, and the rest of the frame is just distorting to follow it, and then the simulation measures the angles of each limb, sends it to the robot. A problem is that the simulation was running faster than the physical robot, and there was no checks to make sure the robot had moved into the right position. The next slide has a video where I'd essentially demonstrating this. So it starts up, which is sort of dips down, lifts up, and then I tried getting it move forwards. As just happened there, it tried to lift a leg, but it hadn't balanced itself. It was just running too quick. And of course, as soon as it goes over too far, the servos can't cope, and yeah, it just struggles. So that one needed some upgrades, which I did end up doing. So as we can see here, I'm just going to show where I upgraded the top. I've got a small RF24 board, I think, so that's just a normal radio frequency. It's quite good. It's got lots of onboard libraries so that you can get it to easily connect to other aerials. That's Arduino Nano, nice small form factor. It's a bit like a Uno in terms of power, but it's just smaller. Here's a reprint of the gears. I've done nice sharp gears, so they mesh a lot better. Those are done on the Ultimaker at the university. And that is the 16-channel PWM board. So I've fully maxed that out with 16 servos, 4 for each leg. That needs further calibration before I can continue testing with it. But like a lot of times, I get bored easily, and I moved on to my next robot. So this is the third robot. It was going to be using servos, and it was going to be an arm initially of 1 and then 2. So 1 would do the printing. This is going to be using a 3D printing pen or a printer head, 3D printer head, in order to print with. I got inspired by some sort of motors and linear actuators on Amazon, so I decided to switch from servos to linear actuators. And so in the next slide will be a short video of me testing the prototype. So what we had here is where the mouse is pointing now. That is an M4 bolt, and that is essentially moving a nut up and down. It's actually fixed into a gear. It's because the nut has a hex-shaped head. I can slot it into a large gear. Example on the left-hand side of the screen where the mouse is now. The 3-volt motor has its own gear, which turns the larger gear and then turns the thread, the bolt, and that moves a nut up and down. This extension piece, it just allows me to attach things to it, keep it shielded. This initial prototype, I changed the clip-on bits on the side so that they had an arm with a groove which held this in place, because one of the big problems is this entire piece will rattle as seen in the video, back and forth as it's operating, and this isn't too good. So we'll move to more details of the actual arm itself. On the upper right is what was initially wanted it to be with the 3D printing pen. I was going to access its electronics and then control it from there. Left hand picture is the final model, using I think was a Sharpie pen as the sort of template model. And in the lower right is all the pieces in their little groups ready for 3D printing. Now here we have the 3D printed out model. I'm using potentiometers, rotary potentiometers for measuring the angle, and Arduino Mega with a LCD screen. I've actually modified a example script for putting information on the screen. So here I am using using the buttons to move the lower actuator to move the whole top of the arm. So this is still in development. I'm currently working on the motor control software side of it. So of course there's only one motor actually being controlled, so I've got to manually shift it across to a different motor at the moment, which is a bit difficult when you're holding a camera at the same time. So you see I've shifted it so the end piece, that bit would be holding the actual pen itself. And that is the last of the 3 robots I've been making so far. Oh, sorry, yes, this is the 3D printing pens from Polaroid, and I've actually connected up 2 wires to the status LED. And that's the only thing I could manage to do because the solder for the buttons themselves were a bit they needed too high a heat, which my soldering iron couldn't reach. So at the moment I'm just working on getting it to draw pictures, and then I'll move on to my 4th robot. So each robot so far has helped me develop the software a bit further. In this case, what it'll be doing is getting it to follow G-code, which is normally what's generated for 3D printing files, to get it to follow a path and just basically just do something with the environment. So it'll be that stage of setting up more involved control software. So this, on that note, it takes me to my final robot. When I initially drew up the little diagram for this, it was going to be using servos, but now I'm going to be using a mixture of both. So maybe servos for the articulation on the neck, for the beak, but it's going to mainly be linear actuators or modified, updated versions of them for the legs. On the diagram bottom left, I'm actually estimated about 19 servos overall at the time, with 7 per leg. And that's not taking into account the feet, because I want to have 2 claws, a little bit like raptor claws for those. But that's something I'd like to work on next, and that'll be a nice challenge because it'll be upgrading the server to work for 2 legs, making sure to improve the software, stabilizing it. And yeah, so that's where that one is going to go eventually. And with that brings me to the end of my presentation. Thank you very much. Any questions?